Okay, hey everybody, I'm going to do um, the lecture 7 in a series of parts. That way I can just don't have to get it all right in one shot. So the first thing I'm going to do is actually just show off something we did in class before, which was a buffer, well, in security context they call it buffer overflow. Um, when we looked at it before, it was a matter of just going past the end of an array. So I have a file called array.c. And the issue was that we had made an array of size 3, and so since we had an array of size 3 and the only valid indices, or since C is 0 index, the only valid indices would be A0, A1, and A2. And so then the question was, what happens, if you write to A0, fine. You write to A1, fine. You write to A2, fine. But if you write to A3, well, the compiler certainly won't stop you from doing it. Although in a context like this, it does have enough information that it might tell you it thinks you're doing something wonky. But really in C, you can do this, and the problem is you're going to start spilling into other memory locations. And so let's add some print statements. Use our address of operator. You see here I'm going to print the address of A3. I can do that. There's really nothing in C that's stopping me from doing that. And so we can compile this. And you see it did give us a warning saying we really shouldn't be writing there. If we run it, well, that's interesting. We actually got a crash. So in this case, it recognized we were going somewhere we shouldn't go, and we actually got a crash out of it. The crashes don't always happen. That's why I want everyone to run the virtual machine so we can all get the same behavior. Now let's just, for fun, add some more variables. Comment when we did something like this in class, we didn't have this problem, or we didn't have a crash. We're getting different behavior than what I did this example in class. And so now we have x and y variables. And we run this, we're still getting a crash. It looks like it's putting the x and y at BD4 and BD8, and then it's putting a after x and y. And we saw this behavior before where it was trying to put all the individual variables in the first addresses. And interesting, it looks like it put y before x. That's surprising. Let's switch it and see if it makes a difference. If we say yx. And now it has x before y. So it's, it really has the right to place it anywhere. We as programmers don't really need to know what memory addresses it's placing it at. And we're really just using the %p to get some intuition built up about how it does it. It looks like we need another array. So I think if we do this, now it still crashes. Okay, so A is at, so it's put B in front of F. So the reason it's crashing is we can see here's X and Y at C8 and CC, and then B's at D0. B has 12 bytes, and so A goes to DC. So A3 is still causing a problem because we are writing past the end of the memory that's allocated. Again, I'm kind of surprised we're getting a port, because sometimes if you go into someone's, we've been using this analogy of hotel rooms. You go into someone's hotel room, it doesn't really matter if it's close to where you're supposed to be. So now let's see if we can trick it into putting B before A. And we have, and we no longer have a crash. So now we've got Y, X and Y at C8 and CC. And then if we add 4 to CC, we'd get to D0. And then A0 is at D0, A1 is at D4, A2 is at D8, and A3 is at DC. Of course, A3 is not really a place we should ever be going because we're past the end of the array. And also, D3 is the beginning of B. So let's put in some values here, like 10, 11, 12, 13. And I'm going to write some B values before that, like B0 equals 6, B1 is 7, and B2 is 8. And then if I print these, then we can see that the A3 assignment going beyond the end of A, which only has 3 elements, 0, 1, and 2, has now spilled into B0, and even though we assigned B0 as 6, the A3 overrode it as 13, and that's what we got. So again, this is called I'm going to do a control B so people can see the stuff at the beginning too. This is called a buffer overflow, and where you see this in security contexts is you'll have you'll want to generate a string of some sort, perhaps a string that you're inputting from the user, and you have to allocate memory, and you say, well, I don't know how long the response is, and so you pick something that you think is big enough. 32, there are almost always powers of 2 because people want efficiency, and if you get powers of 2, then you're more likely to be along so-called word boundaries. You'll learn more about that in 3.14. And sometimes people put in a number like 128 and say, well, clearly the response for your name, when you type in the name, will never be more than 128 characters. And then if someone does, you can write past the end of the buffer and get into other variables and perhaps cause the program to behave unreliably. Now, how to do that and make a crash, that makes perfect sense to me. How to do that and maliciously take over someone's program and make their program do things that you want it to do, that's like, mind-blown type stuff. So, I don't know how all that works, and I think a lot of it depends on luck and trying a lot of different things and just seeing what works, just throwing a lot on the wall and getting what to work. But that's just my own guess. Okay, so this is the first part of Lecture 7, and it's actually just repeating something in class. The rest of the videos will actually be talking about new content.